One of my viewers asked me to complete this tricky division problem. So I'm going to show you what to do when you have a decimal division problem like this where the division just doesn't seem to end. But this division problem can also trick you into thinking that it is a special type of division, which it is not. You'll want to stay until the end of this video to see why. But before I begin dividing these two numbers, I want to point out that the 0 to the right of the 1 in the thousands place isn't needed, because remember, you can add as many zeros to the right of a non-zero digit in a decimal number, and it doesn't change its value. So to make this problem a little easier, I'm just going to cross it out. Now I will need to rewrite this division using a long division box. The dividend of 1 goes inside the box, and the divisor of 301 thousandths goes outside of the box. Looking at the divisor, I need to ask myself, is this divisor a whole number? And as you can see, it is not. So I will need to make it a whole number by moving the decimal point 3 places to the right. And to keep the expression balanced, I will need to move the decimal point the same number of places in the dividend as well. But first I need to place this decimal point to the right of the 1, and then I can move it 3 places to the right, making sure that I put in these zeros as placeholders. So now I have 1,000 divided by 301. And now I'm ready to begin the long division process by following these simple steps. First you divide, then multiply, subtract, bring down, and then repeat until you are done. So I know that 301 will divide into 1,000 3 times, and 301 times 3 is 903. Now I will subtract, and 1,000 minus 903 is 97. I need to continue dividing, so I will need to add a 0 to the dividend and then bring it down. Now I have 970, and 301 divides into this another 3 times. And I will subtract 903 from 970 to get 67. Since I still do not have a 0 remainder, I will need to keep on dividing. So I will need to add another 0 to the dividend and bring it down. 301 will divide into 670 2 times. 2 times 301 is 602, and 670 minus 602 is 68. So as you can see, I still need to add another 0 to keep repeating this process, and the division has still not ended. So what do you do in this situation? Well, you have a few options. The most common way to complete this division is to round the quotient. What I mean is that you can end the division by rounding the quotient to a specific place value. For example, if I wanted to round my answer to the nearest tenth, I would find the tenths place and then look at the digit to the right. And since it is a 2, the 3 in the tenths place stays the same, so the rounded quotient would be 3 3/10. If I wanted to round to the nearest hundredth, I would find the hundredths place and again look at the digit to the right, and the rounded quotient would be 3 32/100. Rounding to the thousands place, the quotient would be 3 322 thousandths. So how can a problem like this trick you? Well, if you do not divide out far enough, this division problem might have you thinking that your quotient is a repeating decimal. Looking at the quotient again, can you see that you might be tricked into thinking that the 2 will keep repeating? But it doesn't. Division problems with repeating decimals not only have a pattern in the quotient, but they also have a pattern as you subtract and bring down. And if you look closely, you do see a pattern in the quotient developing, but there is no pattern when you subtract and bring down. So this tells you that this division problem does not have a repeating decimal. And in order to complete the division, you are going to need to round the quotient to a specified place value. If you're looking for more examples with long division, you'll want to watch these videos next. I hope this was helpful, and I'll see you in the next video.